So everybody go ahead and do File, New. Okay? And it's going to ask you if you want to do a part, an assembly, or a drawing. So basically, if you have, say you have a bearing, that's a part. Say you have a screw, that's a part. Say you have a shaft, that's a part. Say now you want to make a file that shows a shaft on a bearing. That's an assembly. An assembly is more than one part at a time. A drawing is basically like a black and white sketch, as it implies. So we're going to start out by just doing a part. Is it okay? Okay. So.
1 millimeter gram a second.
Yes, everything we do in this class is millimeter gram second. We don't want to be NASA and crash things because we forgot to convert. That would be embarrassing.
What's the dimension standard?
Huh?
What's the dimension standard?
I'm not sure what that is.
ISO, ANSI,
I'm not sure.
One.
Oh, that's probably for the drawing. I don't really care. That's fine. As long as it's millimeter gram second, we're good to go. Is everybody open? Basically, if I start talking and you're not with me, shout out or screech or raise your hand. So, okay. Yeah? Did the Google Doc open? Okay, now go to the left-hand corner file. Hit download. That didn't work? Interesting. Yeah, so I'll send it out as an email. I'd be a little surprised if that worked because it's huge, but I did.
Just go back, click on the back key. I know it opened up the compressed version, right?
Yeah.
You see the details? You see the inside of it? Is that what you see?
No, I tried to.
Okay, so here's what I'm going to do. I'm also going to email it out as an attachment. It's a big attachment, so sort of, it's 11 megs. We'll see how long that takes to reach you. So you know what? We're starting without the starter CAD for now. So okay. So everybody mouse over these planes in the left-hand side. So when you build things, it's basically a series of actions. You can think of it as clay. Say we're building a little man out of clay. You'll have an action called add head, add legs, cut mouth. And all of those actions appear in the left-hand side where my mouse is. This is your origin. See that little dot? That's 0, 0, 0. And these are your 3 orthonormal planes. Everything is dimensioned from the origin and these planes. So what is the most basic thing you could do, not in CAD, but say you're just building. So you gotta keep in mind, CAD is a way of drawing real-world 3D things. And you can make photorealistic things in Solidworks with actual physical properties. So if I was going to build a little man out of clay, and I wanted to make a head versus cut a mouth, what's the difference between that? In one, I'm adding material, and in the other, I'm taking away material. If I make a sphere for a head and then I cut out eyes and cut out a mouth, those are different. One's additive, the other's subtractive. The most basic and the first thing we'll do is additive. Click Extruded Base. Okay? And now it's going to ask you for a plane. Basically, when you sketch for Extruded Base, it's a 2D sketch, and then we pull it out of the plane, we extrude it, and that's how we get 3 dimensions. And the plane is the sketch plane where you're going to draw that 2D picture. So go ahead and click Front Plane. Okay, and now we're here. So we can do all types of things. We can do boxes, lines, circles, splines. We're going to start out with the most basic thing. Click the circle tool. See this one? Okay. Now your mouse looks like a circle, so that lets you know that you in fact are about to draw a circle. And as you move your mouse around slowly, notice that little dashed lines pop up. Basically, SolidWorks is trying to be smart and say, hey, I think you're trying to align with the y-axis, or hey, I think you're trying to align with the x-axis. So we can use this to our advantage. It makes things easier. More advanced CAD actually makes it annoying, but let's just, for now, let's do it. So I want you to take your mouse and put it on the origin. You see how as I get right on the origin, there's a little red dot that says, hey, you're on the origin? Once you have the red dot, left click, and now we can expand the circle. See how we can make it bigger or little? So now pick somewhere in the middle of the screen and click again. So now we have a circle. Does everybody have a circle? All right. Now, there's the most important button you'll ever use is this one right here, Smart Dimension. It's not very smart. I'm not sure why they call it that. But basically, this is how we set how big anything is ever. So click that, and now click your circle. Okay? Now that phi, that diameter, we're going to set the diameter. And the diameter we're going to use, give me one sec. My laptop is being mean to me, is 82.5026. 82.5026. Now, what color is your circle? It should always be black. If something in a sketch in SolidWorks is black, it means it's fully constrained. There are no questions as to where it is or what the size is. Now watch my screen as I delete that dimension. As I try to delete that dimension. Interesting. Dude, is my keyboard busted? Okay, so now it's blue. And it's blue because I can take it and I can do things to it. So I'm going to go back again. 5026. Where's Rob? That's wonderful. Okay, give me one sec. Okay, now we're going to click another circle, put it in the center. Again, when it turns red, you're in the center, and make it slightly bigger. And notice that that too is blue because it's not constrained. Hey Rob, can you please bring me a USB keyboard? Yes. Okay, thank you. Okay, and now this dimension is going to be 98. So take the dimension tool, 98. Okay, everybody there? So that was a circle, that's great. Now we're going to draw a line. There are two types of lines in SolidWorks in terms of straight lines. And you see where my icon is here? You see how there's a little arrow? That little arrow lets you select between the two lines. We can either do a solid line or a center line. So in SolidWorks, if something looks solid, it means it's a real dimension. It's going to use that when it makes the extrusion. If it's dashed or dotted, it means it's just there for for helping you make the sketch, but that won't appear in your final part. So what we're going to do right now is we're going to do it's called the center line, but basically the dash line. Now anywhere on your screen, just click once, then click somewhere else, and then hit escape to get rid of all of the stuff. So that's a line, and it's blue because it's not constrained. So now just delete that line. Thank you. Appreciate it. Apparently.
I have a question for you, Ruben.
Yeah.
So, how do you get your diameters to appear above the part instead of like literally along the diameter line? Like mine, like the 9H and 2.50. They're in between the part. Like if you have a line that represents the diameter,
yeah,
it's on that.
It's all about dragging it around once you've made the dimension. So if you're ever trying to do something and it keeps doing the previous thing, it means you have to hit escape, just so you know. And this plagues me constantly. I keep trying to do something else and I'm still drawing circles. So just, if that's a problem, hit escape. And now, let's see if this works. So this is a boot camped Mac, so the drivers are a little weird. Let's experiment. Oh man, this doesn't work either. God damn it. Ah, it does work. Okay, cool. Awesome, I have a keyboard. Okay, so watch this. Now I can either drag it up and it's there, or I can have it there. Say I put it there and I don't like it. Now, I'd like to drag it, right?
Yeah.
But if I click it, it doesn't do anything. That's because I'm still in the smart dimension mode. So hit escape, and then click on 98 and just drag it out here. And it's more convenient.
Is there any way that we can dimension based on radius?
It sort of chooses automatically, and I don't know how to override it. Okay, everybody take a dashed line, put one line in the middle, and I want to show you something. So if your cursor is directly above the center point, you see how it kind of snaps there to make a vertical line, and a yellow thing appears that shows a straight up and down line? That's Solidworks trying to be smart, saying, hey, you're making a vertical line. It's like the talking paperclip from Microsoft Word back in the day that tried to assist people in writing annoying letters. And now go down, and you see how it snaps to a horizontal line? So we can use that to our advantage. Just so you know, it can be annoying. But for now, I want you to snap to a vertical line, and I want you to put the end of that line in between the two circles. That is because you're too zoomed out. So delete the line. Now I'm going to show you one of the reason why you have to have a 3-button mouse. This is really small, I can't see it, right? Everybody look at my screen for a sec. Oftentimes you get into this weird thing in SolidWorks where it's decided that you have terrific vision. So scroll your middle wheel, and we zoom in. Everybody see that? You don't have to press anything on your keyboard, just scroll in. So, one of the problems that you're having is basically if you're too zoomed out, it snaps to things kind of randomly. If you want it to snap exactly where you want it, you have to zoom in so that basically your mouse is only over where you want it to snap. So, does everyone have something that looks like mine? Okay. Now take another circle and center it at the top of that line. And make just a...
Does it have to be exactly in the middle, or are you just...
No, just wherever. We're about to set the dimension.
Oh, okay. Another tiny thing,
Mhm.
I don't know if it matters, but the end of modeling is a square and the end of your line is a circle. I don't know why.
Hopefully that won't matter.
Okay.
It sounds to me... SolidWorks just does weird things with different video cards.
Okay.
I once worked in all elliptical circles for about a month. Okay, so go ahead and put a circle. And by the way, there are no trivial details or questions too stupid for SolidWorks. If we don't get the beginnings now, it's going to be a really long quarter. So if you have any question at all, just ask it. It's totally fine.
I can make my line smaller and bigger.
Okay, if you want to make your line smaller and bigger, just click on the end and drag it.
How do you how do you move the circle?
You can't. It's locked to the origin now. We'll go over that later. That's a little bit more advanced. Okay, so everybody take a circle and put it at the tip of that line. It doesn't matter what the diameter is right now. Okay, now I want you to set that circle to 3.2. Okay? Now I want you to take the Smart Dimension tool and click on that line. Okay, and I want you to set that distance to 45. And you'll see when you do that, it turns black. Is everybody there? Okay, so vertical lines and horizontal lines are the easiest lines. They're easy because SolidWorks helps constrain them. Now say you want to go to 22.943 degrees. It does not, thank God, have an automatic suggestion for that. So take a, that means we have to set an additional dimension, that being the angle. So go ahead and take another center line, put one end at the center.
It's asking if I want to make it dimension driven.
Say no.
Oh, yeah, okay. Do you have that? So what happens here is...
That's right.
Okay, so you're snapping the wrong. Delete that circle. And then when you put it in again, zoom in so it doesn't snap it.
Okay.
Okay, does everyone's screen look like mine? Okay. Take the line. Oh, there's one more angle it will snap to, which is 45 degrees. We're not doing that. So take the line, and I want you to zoom in at before you place the second end, so it doesn't snap to anything randomly. Look at my screen. This is about how you should be doing it. And just place it somewhere in between the two circles, maybe about a 15 degree angle so it doesn't snap to anything weird. Okay, now I want you to set the length of that line to 45. Now notice something for a sec. Don't actually type it, okay, everybody hit escape, hit smart dimension, hit the line, and don't press anything else. Now, if I move my cursor right next to the line, it says 44.97, which is about right. I place it at about the same radius as the other one. I can also move up, and now I get a vertical dimension, a horizontal dimension, and now if I move to the right, I get a vertical dimension. Again, this is SolidWorks being cute, thinking it knows what you want to do. So if this is ever an issue, the only way to do it is kind of wiggle your mouse and try to position it different areas until you get whatever dimension you want. If it's vertical, horizontal, fine, but if it's radial, then you need to make it radial. So I'm going to move my mouse back over here and click again and make that line 45 long. It's still blue. Can anyone tell me why? Angle's not constrained. So now we have to reference off of something. We can't just say 30 degrees from blah. You always have to reference angles. So click the vertical line and then click the blue line. Now move your mouse in between them and it will suggest an angle. Click, and now put the angle you really want. And in this case, we're going to do 30 degrees. I think. Wait, no, 45. Sorry. I lied. Okay, now hit escape. Is everybody here? No? Okay, I'll give you a sec.
So we have two lines, right?
Uh-huh.
Okay.
How do you select the angle?
I'll show you again. Okay, add something to your guys' buying list. Get a mouse pad. I forgot, my laptop has a little mouse pad built in. And I'm seeing a lot of you having issues because the reflectiveness is screwing you up. So, mouse pad. Okay, take smart dimension. Click on the vertical line once. Click on the angled line once. Move the mouse in between them, and click again. And it'll ask you how many degrees. Everybody here?
It doesn't ask.
Doesn't ask? Okay, now I want everyone to put a circle at the tip of that line. Okay, get smart. Okay, click the vertical line. Click the angled line. Now click in between them. Okay, guys. So this is an excellent point. Go ahead and delete that angle real quick. There's nothing wrong with it. We're just going to practice. This is another not zoomed in enough thing. Watch this. Watch my screen. If I'm way out here, see, I'm trying to click the blue line, but I can't. It keeps trying to see. Anytime you're about to click something, it shows in red. So right now the 45 is black. Now I'm trying to click and it's red. That means I'm about to click it. What's the solution for this? Zoom in. Now I can click either one of them easily. So if you're having issues where it seems like it's not clicking the right thing, it's because it's not. So now go ahead, and before you click the vertical line, notice it turns red. Okay? Now click the blue line, and it turns red before you click it. Now set 45 degrees. Okay. Now put a circle at the tip of that, and make the diameter of that circle 2.6.
So what is this dimension-driven thing? Do we have to click on?
If you're at this point, so basically, if you are trying to set a dimension on something and you get a little error that says something like, well, can you read it?
Make this, adding this dimension will make the sketch over-defined.
Yes, okay. Adding this dimension will make the sketch over-defined. You want this to be a driven dimension instead. You should never get that error if you're doing things properly.
So that error showing up if you accidentally click on the line that says 45.
Yeah, so here, I'll show you. So now I'm going to try, maybe I changed my mind and I want to make this 60 degrees. See? That's the error. That means I've already set the dimension somehow and it won't let me do it again because then it would be over-constrained. If that happens, it means something went wrong. And now see it says the sketch is no longer over-defined.
What do you put on that?
So when that happens, you have to search in your sketch to see what is incorrect. Click on this line. It looks like just about every. Let me stand corrected. Every single error I've now seen on your guys' laptops is because you're not zooming in far enough before you select things. And it's okay. It happens to me on a daily basis, but you zoom in.
You can zoom and unzoom with Z and capital Z too. If you
Okay. Cool. Okay.
Thank you.
Does everyone's screen look like mine? Let me zoom out.
Where do you get the second line?
You go up here, center line, like that.
No, there is a black line being parallel to the other one.
Parallel to the other one. What do you mean?
There's two lines that is parallel.
No, that this is the
Yeah, that's the dimension. Anytime you see random lines, you're like, hey, I don't remember making that. Look if there's a number nearby.
Yeah, but if I do that, that gives me the error that I got before.
Can you sit here? So the two of you can look at each other's screens.
That's fine.
By pan, you mean kind of rotate out of plane? Let's see.
What I do,
So we're going to get to some of those controls a little bit later because it'll screw you up for now.
so it's
Still not working? Okay.
I want to take this guy here and this one.
It's already set. It's set because you clicked on the wrong place. So delete this line.
This is like, I wish you're not just like rated like 4 stars.
This is because you want to do it. So just delete that line and anything that looks like a line there. And then just do it again. Just so y'all know, sometimes your CAD isn't worth saving in terms of a given line or circle. SolidWorks does a lot of so-called smart things. It's hard to get rid of them once they're there. If it's really just giving you hell, just delete it and do it again. Okay, so now I want 6 of these holes. Let's see, can I count? 1, 2, 3, 4, 5, 6, 7, 8. But I'm lazy and I don't feel like drawing all of them. So we're going to do an angular pattern. So, zoom in and click the top little hole. Hold the control key so we can select more than one item. And click the other little hole. Okay? Now you could take your hands off the mouse and keyboard and you still have 2 highlighted little blue holes. Everybody got that? Okay.
again.
So click on the little hole in the top. Hold down control key. Hit the other little hole. Got that? Now go up to the SolidWorks icon. So it hides a bunch of stuff, which is annoying. Kind of hover over the SolidWorks icon and it shows a bunch of things. File, edit, view, insert, tools, window, help. Hover over tools. Do sketch tools. And then do circular pattern. Everybody see on my screen? Okay. Click on that. And now we're going to, this is the number down here. Everybody look at my screen for a sec. So I can set the number. I can set 2, I can set 9, I can set 8. Now there are a lot of controls here. I don't want you using 99% of them. I never use them. Here's the thing, SolidWorks tempts you with every type of advanced function you can. They're annoying, they don't work, they backfire. Think of this as Legos. We want like 4 type of actions we do, and then we want to do them a billion times. We don't want advanced macros or functions in SolidWorks. It will bite you in the ass. So the only thing you're going to do here, just make sure equal spacing is clicked. Hit the number 4 here, and press the little OK check mark. And magically, we have a bunch of holes. Now someone tell me something that is wrong in this picture. The blue. I don't know why this is. I've never been able to figure this out. It's just SolidWorks being really weird. So I can teach you the solution. It may be confusing, but we'll try it. So go ahead and take a circle. Put it in the center. Now zoom in as you drag up, and don't click anything. Watch my screen for a second. So I'm going to get near this other circle and watch. It's going to try to suggest some stuff. It's suggesting I be tangent there. It's suggesting I be tangent there. It's suggesting that I go in the center. It's suggesting that I go on top. Well, on top of that circle. See how it turns red? So we're going to use one of the suggestions, which is we're going to put the circle running through the center of the other, and hit click. Okay?
What did you click to get that line?
That circle.
You just clicked the first circle to get that line that you were just adjusting?
The line.
The one in blue right now?
Okay, so I'm going to do it again. So take a circle.
Oh, okay.
Put it in the center.
I got you.
Now just drag the circle up and zoom way in like I am on my screen, and then sort of just drag your mouse to over the center of the little circle. It turns red. You see a dot, which means it's going to line there, and click. Okay, now hit escape. Now again, someone tell me what's wrong about that black circle that I just made, the big one smack dab in the middle. It should be dashed. If we tried to build a part like this, it would get really confused, because it's like, wait a second, we have nested circles, but you can only have 2, right? It doesn't make physical sense. So, click that black circle, and on the left it tells you a bunch of different things you can do to it. You're going to click the for construction box, and now you'll see it turns checked. So now we're good. Okay? So everybody got, yeah?
My circle never turned black.
Yeah, it doesn't matter. Just make the circle
Okay.
Accidentally.
Actually, mine
You have to unselect it.
There.
to see
There.
if it's
Now
wrong.
click. And escape. There you go. Okay. If you did something and you're like, hey, this should be black, this should be constrained, it's probably because the object is still selected, and it's really annoying. The color, there's slightly different shades of blue, but the shade of blue for it's selected is eerily similar to the I'm unconstrained color. They're confusing. So anytime you think it should be constrained but it's not, hit escape and hope it turns black. Okay, now everyone click, hit escape just to make sure you're clean. Actually, just hit escape 10 times in a row and see nothing happens. Nothing bad will ever happen in SolidWorks by hitting escape. The only thing that will happen is it will get rid of your current tool. It's safe.
My right line dash line is blue.
It is? I hope none of you are offended by swearing, because the videotape is close enough to hear me whispering.
Yeah. Gotcha. And options.
Does everybody's screen look like mine? Okay.
When you did the circular copy, you did something interesting. You took 2 holes and copied them 4
Yes.
times, rather than 1 hole going around 8 times. Which
Yes.
you could also have done.
The reason I did that is because we have 2 different diameter holes. If you look at your screen, one's 3.2 and the other's 2.6. Ken's right, we could get the same geometry by just copying 1 hole 8 times, but then they'd be different diameters. Actually, let's just test. So go up to Tools, and then Measure. Now your icon looks like a little, well, to me it looks like a razor blade, but I know it's meant to be a ruler. And now click on one of the blue holes, and it shows the diameter is 3.2. Now click somewhere off the screen, and click on a different hole, and it's 2.6. This is the second most useful thing in all of SolidWorks, the little ruler thing. That's how you sanity check everything. You think it should be one dimension? Well, let's find out. Okay? So everybody just take a moment, click on the various little blue holes. Is everybody able to verify one of them is 2.6 and one of them is 3.2? Okay? Now, I want you to click click on one hole and then click on another, it doesn't matter which. And now you'll notice it doesn't give us diameters, it gives us the distance between the holes. So, when you click on one circle, it tells you about that circle. When you click on two circles, it tells you about the information of the relationship between the two circles. Now click a third circle, and it's confused. It doesn't tell you anything. That makes sense. Okay, so everyone's screen should look like mine and tell me what the problem is.
Holes are still blue.
Holes are still blue. So, and again, this is pretty advanced. At this point, you could just actually let's just do that, okay? Let's so there are two buttons up here. Everybody look at my screen. This button says I'm done with the sketch, I'm ready to extrude it. That's a good button. This button means I screwed something up, I wish to cancel. I don't remember if by default it will close out without giving a warning. I'm not going to test it here and now. Don't press that button unless you're willing to lose that sketch and not save any of it. Okay, so everybody press the purple button that looks like a pencil. Okay, now you see it's yellow, and you see how it extruded it out? It basically took the stretch, two-dimensional stretch and added a third dimension. This is how it always looks. If it doesn't look like that, it will barf at you, and it means that you screwed something up. Now, this number controls how big it is. See? 50.1, 10, and there are a couple different selections here. Again, most of these different options I never use. The only things I use are the number and this. This says basically how we're going to extrude it. I'm only going to show you two for right now, okay? Blind means based on where I am, just move forward by the number. Mid-plane means I'm going to take that sketch as a middle plane, and I'm going to go a total distance, basically half the distance plus or minus from the mid-plane. That's how you get an extrude with a plane right in the middle. So let's just do blind for now. And let's do 5.85. Okay? And then hit the check mark OK.
Ruben?
Yeah.
When I do exit sketch, it doesn't show the original. Okay.
So pretty.
I feel like I'm not
Can you feel like the corners now? Oh, you want to feel like the corners?
Yeah.
You did everything right. If you guys get random errors, let me know. Yeah.
Some of the circles are still blue, but it's extruded anyway.
Yeah. We're going to go over that.
Oh.
At this point, everyone should have a solid object on their screen. Okay? Now, let's save it. File, save as, and let's call this, first, navigate to your folder. So, another thing is SolidWorks is really dumb about where it saves stuff. Always triple check where you're saving it. Because what will happen is it will save it to your Internet Explorer temp downloads file. But SolidWorks will still know where it is. And then you turn in your homework to me based on a folder that doesn't include your Internet Explorer download temp file. And I can't open your stuff. So always make sure it's in the right folder. In here. And let's call this CS235 Gear Spacer 3. Another word about file names. The same thing with programming later in the course. Please don't name anything foo or var-far. I don't know what that means. It needs to say CS235 so I know it's your file. And I need to be able to tell basically what it is from the file name. This will make your lives really easy, because otherwise, foo is going to bite you. Okay, so everybody's saved. We're good. Now, does anything look weird about... I'm just going to go ahead and tell you this is made out of plywood in the lab. So somebody's tell me what looks wrong in this picture. Yeah, it doesn't look anything like plywood. Now, SolidWorks lets you apply materials. Again, too complicated, pain in the butt. We're going to do simpler. Materials are made basic of a bunch of stuff. I don't want to do it. It's annoying. We're only ever going to do two things: mass properties and color. That's all we need. The mass properties comes in useful for knowing if you need a forklift to lift your robot, which in my case I do. And then also, it lets you know if your counterbalance will work. The color is just, if I made an assembly of 1,000 different parts and they all looked the same drab color, it would drive me nuts. So, go up to SolidWorks. Oh God, it's thinking. Oh no. No. Cool. All right. Next lesson. This happens constantly. Okay? Yeah, this is why you save your work. After every important thing you do, save it. For the love of God, save it. I have lost entire days by not doing that. Okay, hover over SolidWorks and do Edit, Appearance, Appearance. Okay? And now let's pick a color that looks a little bit more woody. How about this one right here? I mean, it's better than gray. Okay, and now hit OK.
Where did you get David?
You hover over the SolidWorks icon,
Yeah.
then do Edit,
Okay.
Appearance, Appearance. Now once you have that, get out of there and then go back in. Yep. Is everybody's wood looking woody? Yeah? Okay, so here's the next thing. Some of these holes are screw holes, which means the screws go through. I don't want them, screws shouldn't be pressing up against the circumference of the hole. Some of these are press fits for dowel pins. They're meant to be very precise. So when you laser cut your part and you have a bunch of holes, you need to test that some of them are precise and then the others it doesn't really matter. So how are you going to do that just looking at this right now? If I squint at it, they look about the same size. We use color within a single part to tell us what is precise, what's a special feature, what we need to double check and measure after we cut. So go back in now that you have a brown thingy. Don't color anything. And I want you to click on the name in the left. Dude, seriously? This is amazing.
Close and restart.
You don't have two copies of SolidWorks in here. There's two SolidWorks icons on the bottom.
I shouldn't. Okay, so everybody, you'll see you'll see the name of the part in the left-hand side. Click on that name and hit delete. Now you should have nothing listed there. Okay, now the little icons there that don't look like what they are, just kind of scroll over them and it'll pop up with what they are. You'll have one that says select body, one that says select face, one that says select feature, one that says select surface.
I don't have the menu.
Go to Edit, Appearance, Appearance. Now you should have it. Now click on the file name and hit delete. Now everybody scroll over. Does everybody see the different, like the feature and the surface and the body? A body is the entire part. Whatever the part is thus far, it's the whole part. if you click that, oh my god.
Just reset your Wi-Fi. It's not connected to the net.
Is it?
Yeah.
Oh, you know what? That's obnoxious.
Yeah, yeah, and I think you probably have the inside password if you're like outside.
Okay, well. Okay, now the wood already looks like wood for the whole part. We only want to select a little bit. So I want you to everybody ready? We're gonna go ahead and click the part, and now click a different color. And probably, my guess, I don't have a computer in front of me, it's gonna turn the entire part that different color, right? That's bad. You can't click anything in the part without selecting the whole body. When you're changing appearances, you have to first select what type of thing you're going to select, like a surface or a feature or a body, and then click the part. So go to that list, delete the name of the thing, and when you've done that, I want you to select surface. Okay, face, sorry, the second one, select face. Now zoom in and select one of the smaller holes. And you see how it pops up face 1 in the left hand? That's a list of different things that you're about to color. So I want you to select all 4 of those little holes. These are the press fit holes. Okay? And now on your solid model, you'll see there are 3 light blue ones. That just means they're all selected. Everybody got that? Now, my own personal way of doing things is I call any type of special fit bright navy blue. So that's what we're going to do for the course. So pick this blue in the middle, and they turn bright navy blue. Okay? Now hit the check mark. Now I'm going to save you the trouble. You cannot select, at least I can't, maybe you can, but I can't ever set multiple colors without first going out of that dialog. If you want to select 2 holes red and 2 holes blue, can't do it. All of them are going to end up one color or the other. So you have to, every time you want to change a different color, go back, hit escape, go back in, edit, appearance, and do that. Cool. Oh, my thing's not brown. I'm sad. Okay. And go ahead and save, lest you lose internet. Okay, let's see what else I got here. Okay, now everybody pull up your measuring tool. That's Tools, Measure, and measure the outside diameter. Now, just look at my screen for a sec. The select, for some reason, everywhere else selecting things is blue, but when you're with the measuring tool, it's bright green, just so you know. So, have I selected anything here? Anybody on my screen? I have, but I don't see a number. Sometimes it hides this right here. Click that little tab. So my diameter is 98. Cool, that's what I wanted it to be. Let's test the diameter of this inner surface. Diameter 82.5, sweet. Now click the origin and click one of your holes and see what that radius is.
How do you get it when it hides?
You see this little button here?
Yes.
Okay, does that work? So, this works pretty well. Now everybody do the following thing. There are 2 ways, so basically, another terminology, anything in the left-hand side is called a feature. If it's in yellow, see how this is yellow right here? That's called a feature. Now, click the plus sign. Features are basically actions performed on sketches. An extrude is a feature, an action of extruding on a sketch. A cut is a cut action performed on a sketch. Everything in SolidWorks is some type of 3-dimensional action performed on a sketch or curve. So we can keep the sketch even if we don't have the feature. So I want you, actually let me test this first because I haven't used this version in a little bit. Okay, go ahead, click in the left on the boss and hit delete. Just click on the yellow icon, the boss extrude 1, and click delete. And you should be left with just a sketch. Okay? Now hit Control Z. That's another best friend in SolidWorks. I use it every hour. Now say that you couldn't do Control Z. Go ahead, click it again, and hit delete so you're left with just a sketch. If for some reason, say we saved right here and we can't Control Z. Well, it's the sketch. We didn't lose any information. All we lost was the axial extrude direction. So you can start an extrude either on a plane from blank and then extrude it and make a sketch and extrude, or you can start from a sketch and just extrude that. So click the sketch and then go SolidWorks and then click the extrude boss base thing. Boom, we're back in business. 5.85. Okay?
Another button.
If you don't have the button, go to SolidWorks, insert boss. So everybody look at my screen for a sec. Again, SolidWorks configures very differently on different computers and you can change it. And so these buttons here are also all in little drop down icon things up here. SolidWorks, insert, boss, extrude. Okay? Now notice we lost the coloration. So let's go ahead and add the color back in. Edit, appearance, appearance, delete the name, select the select faces, select the little holes, select navy blue, and we're done. And go ahead and save. Make sure to save because we're about to intentionally wreck your part. Okay, is everybody with me? No?
How do you rotate a part around on the screen? Because I managed to get it in planar somehow. Like, I managed to do that.
Sure. Arrow keys. You want to rotate it around?
Yeah.
Arrow keys
Just
up,
the
down,
arrow.
left, right.
Everybody? Is everybody still trying to color?
Yeah. Yeah.
Okay. Let me know when you're done. Is it Taru?
Oh, it's done.
But Taru? Your name?
Oh, no. Rohan.
Rohan, I'm sorry. Okay. Yes.
How do you rotate it?
That's the next lesson. We just brought it up.
Just color surfaces,
Yeah. Okay. So now we've got an interesting object that we can. It's three-dimensional, so it makes sense to look at it from different views. That's why I need a 3-button mouse. Everybody, hold down your left mouse key.
I can color it.
It's okay. Let's come back to that later. Let's do the rotation for now. Hold down your left key, and it doesn't do anything to the object, right? However, we can select things with it. If you want to select a whole bunch of stuff in assembly, that's how you do that. We don't want to do that. Oh God, what was that? That was terrible. Okay, the way I rotate is I hold down my scroll button. Not scroll, I just press that as a button, and then I rotate, I move the mouse, and that rotates it. Can everyone rotate their object like this? Stop calling me. Everybody good? Can everyone rotate? Raise your hand if you can't. Okay, so leave it in some weird angle. And, perfect. Okay, is everybody's in some weird angle? Say we decided we don't like, we screwed up the diameter, we need to modify it. The way you modify sketch is you click on the boss extrude, right click, you see this little button, look at my screen, edit sketch, click edit sketch. Now, it's kind of hard to see, right, on my screen, it's still at a weird angle. So the way that you get to standard orthographic or isometric views, orthographic is always straight on along one of the primary axes. Isometric is at some weird angles. See this button right here? View orientation. These are the different views. So these boxes that only highlight one side give orthographic views. These diagonal ones give the diagonal views. This is the most important one right here. Normal 2. And now my sketch comes back up normally. This will happen constantly. Get to know that menu. Okay, now exit out again. And let's play around with those views. So go ahead and press each of the different face selectors and just look how it shows you a completely different view. Mess around with the isometric too. Okay. Now go ahead and zoom way out. Oh, actually no, let's do this first. Okay. So the way you translate is you hold down the middle scroll wheel like a button and the control key at the same time. And then when you drag, it translates instead of rotates. So this is why CAD in SolidWorks is always two-handed. Your left hand does things like the control and the shift keys and numbers, and your right hand does all the mouse stuff. So, can everyone translate? Are we good? So let's practice them together. Let's rotate just the middle key or middle button. Now let's hold down the control and translate. And now just using the scroll, let's zoom in and out. Okay, now oftentimes SolidWorks just does crazy stuff. I'm just going to go ahead and zoom way out and I'm going to translate, and where did my part go? It's small, it's far away, it's scared and needs a friend, and it doesn't know where it is. And I can't find it. See, I'm rotating and I don't see it. When this happens, and it will happen many times in Lab 1, go up here and hit the isometric view. Boom! It's back. You learned a lesson. So we're good. So now that we know that, remember we left the sketch a little crazy. So go ahead and edit the sketch, and then select the normal face so that we're back in it looks normal. Now I want you to take one of the blue circles, click on the diameter of a blue circle, not the diameter, okay, click on the middle of one of the circles. Watch my screen, see that? Ooh, that's bad. This is what happens. Say you made a part, and then you accidentally pressed something, and now it's all screwed up, and SolidWorks refuses to let you go back to happier days. This is why you want everything constrained. If everything's constrained in black, SolidWorks will not let you drag it and screw it up. If things are blue, SolidWorks will let you do whatever you want. If this happens, you can either Control Z, or watch this. If I just totally say I deleted this, and I deleted this, and I changed this to 78 degrees, and I'm very unhappy, as long as I'm willing to sacrifice all changes in that last edit sketch, I hit the X, and it's going to say discard changes and exit. Yup, and I'm back to normal. That's the nuclear option. That's the E-stop on SolidWorks. Now let's.
It just takes you to the last save one?
No, it takes you to before you started editing that sketch. So right here, I right-click and I hit Edit Sketch. That's the start of that session. When I X out of that, that's the starting point from which I delete. So let's fix it. So I want everyone, basically the way that you constrain angular patterns is by forcing some of those copies to be located on basically something concentric. So let me watch my screen and I'll show you what I mean. Let's zoom in and collect the center of the little circle, hit Control, and click the diameter of the big circle. And then on the left side, I've got some different things. See Fix? Fix is bad. You will never have an excuse to use Fix in SolidWorks ever in a million years. This will result in $1,000 robots that don't work. What happens when you hit Fix, SolidWorks says, until you hit that button again, it's just going to keep that hole no matter what. And it does weird things, unexpected, non-linear things. And the problem is, basically, if you do other things after that fix, and then later you unfix it, it retroactively changes everything. So say that you made one part in an assembly based on another, and you sent that part out to get machined, and it was $4,000, and it comes back, and then you unclick fix, and it changes everything, and you're like, holy crap, what happened? It's because you hit fix. Never, ever, ever use fix. So now the other two options are either coincident or concentric. Concentric means it's going to take that circle and place it at the middle. We don't want that. We just want coincident. That means that point that we clicked will be on that circle. We're good. Now hit the check mark OK. We're still blue. It actually takes 2 of these, I think. So now do another blue circle. Click the center, click the diameter, hit coincident. Boom! We're black.
So my Solidworks kicked me out because it said I didn't have a license, and then I restarted and it says I can't find the server node.
Okay. And that's got to be an internet problem. So note to self, we'll hold this in a different room next time. In terms of SolidWorks. Try to make sure your internet's live. Go to CNN or Google.
Which order do you have to click them?
Doesn't matter. As long as you click both that big circle and that little dot, then you're able to hit coincident.
Which big circle? The one defining the individual hole, or
This one, the middle one. Basically, whatever you want to lock it onto.
Okay.
Yeah. The alternative is you could have just drawn every single line you want. And you know what? I'm not gonna hold against you if you do that at all. In fact, that may be a very smart thing for you to start with. Now, I do warn you, we're going to be doing crazy stuff like 80 teeth gear, so that's going to be prohibitive for you in terms of drawing lines. But if you want to do that for 3, 4, 5, no problem. That's fine.
Sorry, Ruben, can you say what we're supposed to constrain again?
Yeah. So go ahead and click the center of a little hole. Hold down Control and click this center circle.
Holding on control?
Holding on Control. The only way you get to select more than one thing at a time is with Control.
Oh,
And then hit the coincident button in the bottom left corner. Okay, and now do that for another hole, a different hole, and then everything should turn black. Is everybody's stuff black?
Mine's not doing it. Yeah, also
Yeah, it requires multiple. All right, everybody. As a reminder, one hole is not sufficient. It takes 2 holes. 2 blue holes. Okay. Everybody's stuff black. Good. Now, remember how before we screwed up our drawing by selecting the center of one of the little holes and dragging? Try again. SolidWorks will not let you do it. This part is done. Go ahead and, yep.
Is there a way to check if we haven't forgotten anything?
You,
Like maybe something is blue, we just forgot about it.
no. Just visually. If everything's black, you're good. Okay. Now one last. So exit this. Save real quick.
Mine says overdefined. The item is unsolvable. Item complete.
Okay, that's the next lesson. Come in here, edit sketch. Say I take another little circle, and I'm going to put it right here. Everybody watch my screen for a sec. Is that physically possible? Nope. Not physically possible. If I try to exit, cannot rebuild the feature using this sketch. Show problem. Sketch has intersecting contours. This is like 99% of problems in sketches in SolidWorks is something is nested, so you have like 3 circles in a row, or something is overlapping. So you see how it's highlighted the problem area? Alright, so you just delete that, and then I'm done.
Can I just point out something?
Yeah.
When you're editing a sketch, at the bottom right-hand corner, it actually does say if you're fully defined under constraint or over constraint. Right where it says editing part in the lower right-hand corner of yours, see it says fully defined.
Hey, very well done. Okay, thank you.
the errors?
It just pops up, and then it will highlight in light blue. Don't worry about that. That'll be okay. So everybody save that. That part's done, and that is one of the parts from your homework. Okay, now we're going to try something a little harder. We're going to try something out of plane. I'm sorry, there's just no way. It's, you know, it's a shot and it's a big needle, so we're just going to go for it. So go ahead and do File, Open, and All Files. Basically, it'll hide a bunch of stuff from you. So look at it, and you see this drop-down menu on my screen? There are like 20 different files I can do. So generally, if I can't find something, I do All Files. Now I want you to click on the Rush Gears, and then it'll have a .step. Just so you know, there are a couple universal file formats that are non-proprietary to SolidWorks. They're .step, .stp, .igs, .stl. Anytime you see one of those, it means it's universal. So go ahead and click Open. Okay, and it's going to say, do you wish to run import diagnostics? No, it is useless. Yep.
Do you want to proceed with feature recognition?
No. This is all stuff that SolidWorks does that is useless.
So do you never use it, or we don't use it right now?
Never.
Okay.
It's just totally useless.
Sweet.
Okay, so this is a Bevel Gear. Now you'll learn more about this on Monday, but these make right angles. This is basically like a right angle version of a spur gear. Okay, so the first thing we're going to do is just click on the planes and just see where they are. You see, I'm highlighting planes. Go ahead on your screen. Click on the planes and see where they are. Just so you get an idea of where the origin is and what we're dealing with. Now, I want you to rotate your gear to look like this, and I want you to click that, and it's highlighted. We can use any planar surface to start a sketch. Doesn't have to be a plane like we did in the last case. So with that highlighted, hit the Extrude button. Okay? Now, this is at an angle, it's hard to draw. So go to this little view thing and do View Normal. Everybody here with me? And I'm actually, you guys are doing really great. I took a course in Pro E in undergrad, and I would have been crying by this point.
It's on the inside.
Yeah, it's good. Actually, at the end of one of our finals, it was like a 4-hour final. One of the girls' entire final, 4-hour final, was deleted mysteriously from the server. And I don't think she cried, but that was upsetting. Okay, everybody here?
Which file do you open?
Do all files. And we're recording this. If you guys have to go, we'll put it back on. That's fine. Okay, good. Let me show you guys. Watch my screen. I'm just going to keep toggling this back and forth. You want anyone tell me why this is happening?
Two normals.
Yeah, I can either have plus or minus normal. If you don't like the normal you got, press the other normal. Okay, everybody here. Take a circle, put it in the middle, and drag it out around here. Now dimension it to be 8.1. I'll explain these dimensions in the, oh my god. Did everybody's circle blow up? Way bigger? Okay. Anyone know why? Yeah, this is an inch part. This is one of the bitches of SolidWorks and US manufacturers versus Japanese manufacturers. Japanese manufacturers is always metric. US is almost always US. I'm sorry, there's no way around this. We're screwed. So just, you always have to divide by 25.4. So now double click it. You see how it says inches IN? Divide 25.4. Now before you hit enter, a note. Almost every single place where you, in SolidWorks, where you're able to enter a number, you can enter an equation. Now, we're not going to be doing like variable equations where we set x and y and we're doing cotangents and stuff. But I always do stuff like, this is a good one, watch this. I'm going to do 8 is my nominal diameter, and then I want to do a 0.1 offset, and then I want to divide the whole thing by 25.4. Boom! You can do equations in here. Just don't use variables because that'll get you screwed. Everyone's circle should shrink now, showing that we're back in metric. Now make a second circle bigger than the gear, and I want that to be 25 millimeters. So please dimension that circle to be 25 millimeters. And let me know when we're good with that. Everybody good? I'm glad I didn't get soup for tonight because cold soup is nasty.
25 millimeters? So,
excellent.
At least for mine, I don't have to do the whole vision thing. I can just do 25 and then.
You're good. That's awesome. I don't know how you did it, but I congratulate you. I wish mine did that. There's about 99% of Solidworks I don't know. And this is one of the things where if you go to a place like, well, Lockheed Martin used Pro E, but say you went to Lockheed Martin Prime, they'd probably use Solidworks in Bizarro Land. And I'm just going to take I guess we're posting this online, so I'll be very polite. People who do this for a living are snobs about CAD. They're like, yeah, I know these advanced functions. I don't care. That's not the point. The point is getting your parts correctly quickly. So the finer details of yours works and mine doesn't, I don't understand. If you type in 25 millimeters and it looks correct, awesome. If it doesn't, divide by 25.4. Okay. Now everyone hit the purple "We're done" button. And you see how it turns yellow? That means that we're good. Sweet. Now we're going to use a different type. We don't want to do blind in this case. We're going to do up to surface. Now up to surface means it's going to extrude until it hits a surface of our choosing. So we're going to click, see this? Now this is very important. If you try to do something that is physically impossible in SolidWorks, it will barf and it will crash. It's just the way it is. So in this case, you want to zoom way, you see how it's highlighted red? I could get away with doing this, but I could also move my mouse at the last minute, select this or this, and there's a good probability it'll crash. Always zoom way in. Be certain. You can move your mouse quite a bit. You could spill your coffee and have a rabbit bite you on the foot, and you still won't move your mouse enough to click the wrong thing. Click this, and see how it turns yellow and goes up to that?
What if the part is in yellow? What if you just have the 2 blue circles?
That's bad.
Okay.
Well, did you click the other surface?
There's no surface to place. I just have 2 blue circles hanging out. They look good.
Okay, well, everybody else hit green checker mark.
Talk amongst yourselves.
Basically, okay, if your guys' computer is having issues now, you probably need a different computer or to change something. If it's because you're in Mac and dual booting, don't do that. If it's because you have a 1998 laptop, don't do that. This is a single part. It's not particularly complicated. I swear, if you're having issues right now with your computer, it's going to be a long quarter.
Oh, yeah, yours says boss extrude, but mine just says sketch.
Yes.
What did I do wrong?
You haven't extruded yet. You have to click on it.
Yeah. So every now and then, you'll press the wrong thing, and you'll succeed in making the sketch, but it won't actually do the feature. If you have a valid sketch, just select the sketch, and then hit the button for the feature, and then you don't have to resketch anything.
So once I extrude it, do I select what part do I select? Can you just go over that again?
No.
So where did you select it to extrude?
Okay. So going back in here, see right here? Okay, does everybody's part look like mine? You must not be doing up to surface. You clicked the wrong surface.
I did, but it's not working.
Select this thing, this. Extrude. This is right. After surface. Zoom in like that.
Yeah, you guys, sometimes after you do something, it'll look kind of funny, like... You're good at this point. This is 8.1, this is 25.4, you're good. Sometimes you'll make an extrude, and it will look... Okay, well, let's just practice so you see. Okay, everybody right-click Boss Extrude.
I don't know which one I have to click.
Oh, zoom in. This. Everybody right-click Boss Extrude. Okay, what were we talking about? Okay, we'll start from scratch. Everybody delete that if you have it, and delete the sketch. Select this face. Extrude. Normal.
I mean, so when you opened this part, it went through like this import process or something. What
Yeah.
did you do with the import process?
Nothing. Just hit no continually.
Just hit no.
Yeah.
Oh, okay. I think I had guessed.
Okay. Draw two circles. The inner one is 8.1 divided by 25.4. The outer one is 25 divided by 25.4. We're done. Up to surface. Rotate the part. Select this surface, and we're good.
What the heck did you do actually? What did you do?
Oh, all right. So real quick, if you don't want to delete something, but you want to basically roll it back, right-click, and you see this little thing here, suppress, goes away. See how it's blanked out here? Now we right-click, unsuppress. This is a double-edged sword. You will fall on it. You have to use it sometimes, but beware it's dangerous. If you have a bunch of stuff after that, and you hit in the middle suppress, it suppresses everything beneath it. It's a parent-child relationship. When you then unsuppress the thing you just suppressed, it doesn't re-unsuppress all of the children. So then you're going to be clicking one by one. Just be careful.
So why did you do this extrude right now?
Okay, so let me show you this. So here's the reason why we did this. I don't like making gear teeth from scratch. They're very complicated. There are very complicated mathematical functions. Don't make a gear teeth from scratch. Never in my life have I ever made a gear tooth from a function or an equation, ever. And I've made a lot of gears. You can either get a program to generate it. I usually just download it from a manufacturer. I mean, they sell these things by the millions, so they work. So I download it from a manufacturer. But usually you want something special. You want a clamp, or you want a set screw, or you want it to be this long, or you want it to be a different bore. In this case, this center hole is a half an inch, which is 12.7 millimeters. But the shafts we're using in this class are 8 millimeters. So what we did is we just took somebody else's gear teeth and made it fit our shaft. And we made it fatter because we're 3D printing it, which means it's kind of weak, so we just want more material there to be safe. Okay, we're going to move along. Everybody good? Anybody having a hard time?
Yeah.
Yes.
Yep.
Yes. So I'm at the point where I have the circles. And so I do extrude on, like, what do I select before I extrude? The.
Say it one last time.
So.
So let's sketch.
No,
Okay.
my buttons are all.
Hit
and then
extrude.
I
Okay.
throw it back.
Change that off the surface.
Right.
Now rotate the part of it.
So it's supposed to move like temporarily.
So that's what's happening. See? We just made that the body. Yep. And now keep rotating.
And then you're saying that the reason more?
More. Zoom in and select that.
Just so the features are applied top to toe. So if you have like 25 and then you suppress the other mouse over and unsuppress that one, it doesn't unsuppress the building.
Y'all, if you don't have an external mouse, by the time the lab goes out, you're all screwed.
When will the love go out?
Probably over the weekend. Okay, next thing. See you on my screen? Select that surface. Extrude. Make it normal so we can see it. Now, rotate your part a little bit, and you see how there are two circles? In terms of this surface and this surface? Now, when we go back normal, it disappears. You can't see it. It's bad. There are different view modes in SolidWorks. Everybody look at my screen. See display style? Right now, we're in shaded but no edges. Here, shaded with edges. Hey, I can see my circles. I could also do wireframe. All types of wireframes, hidden lines, no hidden lines. When you do shaded with edges, it slows down your computer. For a few parts in an assembly, it's really not a big deal. So let's leave that on. Take a circle, put it in the middle. Don't click it yet. I want to snap it to this circle. See that? Snap it to that circle. But you make sure it's red before you do it. Now that's kind of difficult. So actually don't do that. Click about here. Everybody see my screen? Put a circle there, hit escape. Now, I could say, hey, well, I could measure the diameter and then dimension it to that diameter. What's the problem with doing that? If I ever change the other thing, I have to change everything. So what we're going to do is make it do it automatically. Click the circle, hit Control, click the bigger circle right next to it. Now in the left-hand corner, see on my screen, co-radial. Co-radial means they're going to be identical radii. Click that. Now I have a black circle, fully constrained. Perfect. Exit the sketch, and we're going to do up to surface yet again, and now we're going to select that surface there. Oh God, what's the problem? Anybody know?
You lost everybody.
I lost everyone. Okay, that is a problem. Okay, who here has this circle?
I cannot find the middle point. I never lost this.
We had to select the face. You forgot to select the face.
No, I selected the face.
Yeah, well, okay, so you select the face, then you can draw the circle.
Yep.
Then you dimension it, then you had some button on the left.
Yeah, okay. Okay, everybody, I'm starting over from the... Okay, is everyone in this sketch view where I am right now? Sans the yellow. Okay? Everybody, I hear some talking. Select a circle, put it in the middle, drag it to about here. Okay? Press escape. Now select the blue circle, hit Control, and hit the circle next to it that already exists. Your screen should look like mine.
Is this another one?
If you've already got it, you can leave it. I'm redoing it because some people didn't get it.
We did it for the other circle.
Yeah, we're doing 2 circles.
Okay.
Hit co-radial. See this button right here?
I don't get that button.
Then, if you don't get that button, both circles are not selected. Yeah, so you have to select that.
It's a hole, right?
Yep. Okay, now you got radial. Okay, the goal is we're going to do this twice. So now we take another circle. We select that and this. Hit co-radial. Exit your sketch. So basically, before I press the button, everybody's got to have it look like this.
Which circle are you making a code radial with? I see, like the inner ring or the outer ring?
Both. We've got 2 circles.
Okay.
Basically, we're trying to extrude an annulus or a ring here.
Gotcha.
See how I have this circle on the inner and that circle there? Is everybody here? Hit this, and then do up to surface, and then select this surface here in pink.
No. Okay, so it's the second circle was the same as the first circle?
Yeah.
And then what?
And then that's it. Just exit the sketch. But don't use the X. Use the little purple pencil thing. Okay?
Okay.
Now do up to surface.
Up to surface is a view mode?
No, it's over here. See?
Direction. I don't have that.
Okay, guys.
No, but it's because I did the circle ones. I didn't really understand what they.
So I'm not trying to be mean, but if we want to get through these parts, some of you will have to either catch up or watch the rest of it online. But I want to make sure I show you the basics or so that we can get through it. So at this point, if we rotate your model, you'll see we have that 8.1 millimeter all the way through. That's cool. That's what we want because we're going to be sticking a shaft all the way through.
So it's the sketch is intersecting contours. What does that mean?
Yeah, okay. Discard changes and exits. Delete that sketch. Yes. Just select that page right there. Nope. Nope. Here. Oh, you want. Rotate your part. Select this space here. Yeah. Yep.
There should be a hole.
Now go features.
So if maybe should
Yeah.
Extrude.
Oh, no.
Now. Okay, now do circles. Back up there. Now hit escape. Press that circle and the circle. All right, we're going to steam ahead until we get through it. Okay, this is the critical part. You guys really want to get this. This is the first time we've ever done a cut. Okay, we're going to do a non-standard cut. Everybody select right plane. Now Up here, see on my screen, Extruded Cut. Press that. Now change the view so it's normal. And I'm going to wait for everybody to get here.
How do you select right plane?
Just click on it in the left-hand side, where it lists right plane. No, Extrude Cut. Here, I'll do it again. Right plane, Extrude Cut. Okay, everybody here? All right, now turn to wireframe so we can see through the part. Okay? Now I want you to take a construction line. See this? When you put the start of the line along the midpoint here, we get a midpoint constraint. This is one of the most useful things in all of SolidWorks. Click there and drag left and see how it wants to snap horizontal. Let it do that. Hit escape. Now we're going to do a rectangle. We haven't done that before. There are two types of rectangles. Ones you define by corners and ones you define by centers. Press a little arrow and select center rectangle. Everybody with me? Now click here on this line and drag the rectangle up and let the corner snap against that top line. And then press escape. Everybody with me? Smart dimension. Click the left-hand side of the rectangle and click this left-hand side here. Right here. See that dimension? And set that equal to 1 millimeter. So 1 divided by 25.4. Now zoom in and set the dimension of this line to the same thing, 1 millimeter. Now everything is black. That's good. See this little dot here at the end of the line? It's the only thing that's blue. That doesn't matter. The line's still horizontal. Doesn't matter how long it is, we're still good. If you really want, drag it to the origin and then it'll turn black. Does everybody's screen look like mine?
Sorry, what did you say as 1 millimeter? The horizontal one?
Yeah, so the dimension from here to here,
I see.
and the dimension from here to here.
Got it.
Don't worry about the blue, it's fine. Okay, is everybody with me? Now exit the sketch with the little pencil thingy. And if you did it right, you'll see sort of a yellowy thing. This is what we want. Set it to 1 inch. And hit the green check mark.
How do we get to the yellowy thing?
Exit the sketch through the purple pencil. 1 inch. 1 inch. Basically, we want to cut all the way through that body. Just half of it. Okay, now turn back on the shaded modes. This is what our part looks like now. Look at that. That's sweet. Does everyone's screen look like mine? I'm going to give you all a minute. I see some frantic clicking.
What did you do after creating the yellow?
Just type in the number 1 and hit the green check mark. Guys, another point, nothing in SolidWorks happens until you press the magic green check mark. Maybe enter, I don't remember. I always check the green check mark because it's safe. Has everybody got a cut? Okay. I propose we finish this when we finish this part. It's up to you. This tonight is completely optional to begin with, and how long you're here is completely optional. But this is about the hardest part you have to do. So if we get through this, I think it'd be pretty good to go for the homework. So I'm just going to go full steam ahead, and we'll see how far we get.
Should we be overriding this file with saves or do some of this?
Yes. In fact, everybody go ahead and save now. Thank you for reminding us. Save as would Keep the same title, just put CS235 in front. Everybody, when you're saved, let me know.
Wait. So the original file was a .step.
Yeah, when we save it converts to SLDPRT. The difference is I want your SolidWorks files. Please don't send me step files. When you save what you opened a .stp and you've given birth to a new type of file, a better type of file. Okay, everybody saved? We're all good? See my screen? We'll wait for a sec.
What was the last step you did for the cut? I have the rectangle.
Okay, does it look like this?
No, no yellow.
Okay, do you have a sketch down here?
Yeah.
Okay, hit the sketch. Select that. Now look at my screen. Press this button. Now does it look like it's going to cut?
Yeah, set it to 1 inch.
Yep, set to 1 inch. So I don't know why, and it does this to me all the time, where like you did everything nominally right, and it just refuses to do the feature. I think it's because they have monkeys programming at SolidWorks. It's just non-deterministic bugs, which are my favorite type to debug. So.
Okay, so it's at 1 inch, and you press the green check mark.
Yep, and now you've got a cut.
No, it says the sketch is both open and closed.
Oh god. Is your center line dot dash?
Yes.
Yeah, the reason I'm doing 1 inch is arbitrary. I just want to get away hard. Good? Okay. We're about to get to the exciting part, everybody. Okay. Now select this face, Extrude Cut. Now change the view orientation with the normal button so we can actually sketch something. Okay. Now take the rectangle, but this time we're not going to use a center. Get the corner rectangle. Okay. Now see how I'm selecting the middle? Go up like this, just above the gear somewhere, doesn't matter, and hit escape. Now smart dimension the long side, just do 1 inch. And then between these two lines, do 1 millimeter. Interestingly enough, SolidWorks used to give you a 2-year license for $100. Now it is a 1-year license for like $125. They used to let you install 2 copies per license, and now it's 1. And soon they will require fingerprinting and DNA evidence to make sure that they know who you are and where you live. Also, we're sponsored by SolidWorks. Thanks. Okay, does everybody's screen look like mine?
That cut bisects the semicircle you cut. Where's the?
It will. Uh-huh.
Okay.
We're making a clamp.
Right. Okay. Is that clear?
Yeah. Everybody good? Okay, we're all good. Press the little purple pencil mark. And this time we're going to do up to surface. Anybody know why? This is a clamp. I guess I haven't told you what clamp is. Okay. This surface here, you see, zoom in, this semicircle, that's the surface. When it turns yellow, you're good. I'm going to wait for everybody. So, up to surface here.
The bottom
Just the bottom, right?
Yeah. Everybody here? Okay, and now a green check mark. Well, let me show you what it looks like. So now, see how I've got this thing is free? It's bent over. If this were a shaft right here, this thing, I guess I can't draw here. The shaft goes in here, and this thing is free to bend down this way. We're going to put a screw here and clamp it on. That's what we're trying to do. Now I'm going to redo it because it looks like we lost some people. So where are we lost? Does everybody have a sketch that looks like this? Up to surface. And now rotate the part. You guys are champs. This is good. Okay, everybody got their sketch? Now press the purple pencil. Do up to surface there. Oh god. Oh, that you pressed the wrong button. Okay. Wait. Nope. So here's one of the many confusing things about SolidWorks, our beloved sponsor. They everything's called an extrude. I guess that makes sense. But when I see that, I just start clicking willy-nilly anything that has the word extrude in it, which is bad. That'll either give you a boss, a positive adding material, or a cut taking away. Okay, everybody got this? Okay, the next step. Okay, this one's easy. Select this. Everybody on my screen for a sec? Everybody got this? Extrude cut. Take a single circle, center, and just drag it somewhere big. And whatever that big is, just say yes. Purple pencil. And then this one. Okay, this is a new type. Rotate here. Offset from surface. Over here. And now click this surface. And now make it 8 millimeters. So that's 8 divided by 25.4. So what we're doing is, this is an example of the company that makes this gear thought they would like a given hub width. And we don't like that hub width. We would like it to be smaller. The only way we can get rid of it is to cut it away. So that's why we're doing this. It's not arbitrary.
So it's 8 millimeters?
8 millimeters?
8 millimeters.
So now you should have a shorter, stubbier thing.
Oh, sorry, what's the offset?
What's the offset?
Oh, yeah, let me show you again. All right, on the screen, offset from surface, and then click this one right. Actually, sorry, this one. Sorry. Ha-ha! I have thwarted you and vicariously myself again. Okay, and now you click the green check mark.
What was the value?
8 millimeters. So 8 divided by 25.4. Okay. This next one's tricky. So everybody rotate your part to look like this.
Could you hold on one second?
Yep. Okay, who doesn't have a cut? And I'll come over and help you.
I lost everything.
It's okay. It's recorded. Also, if you want, if anyone hates this and wants to come back for more, which is ironic, we're doing it again tomorrow at 2 o'clock. The exact same parts. You get a second crack at it.
So tomorrow we'll be here too.
You're good.
So you said this gear was in the
Yeah, you do it for me.
Excellent. We're doing the rest of the extrude.
Yep.
Extrude one maybe, and then you walk me through it so we don't violate the...
Okay.
Yeah. Exactly.
I selected the wrong surface, so going back. Okay, now I have the circle. So now we're
I lost it. I couldn't understand what it was.
Okay, select sketch. Extrude cut. Offset from surface. Rotate the part. Yeah. Ever? I'm going to send out a reminder email tonight, and then I'm going to ping you maybe every 10 hours or 4 hours or 5 minutes until everyone has a mouse. Okay? Okay, next step. This one's tricky. Everyone rotate your part to look like mine. See this surface here? Select it. Extrude cut. Normal, so that we're actually looking down on it. Okay, now this is annoying, but do the wireframe view. Let me know. Everyone should look like this. We all good? Here. Okay, now take a construction line. See this right here? I'm going to zoom in. See that thing right here? Put it there. Put the other side over here. On the very outer one. So I'm going to do it again. Take a construction line. Zoom way in, because we're looking at multiple surfaces here. Take the outermost line and put it dead center, and it will snap to. And then zoom out and zoom in back over here. God damn it. Okay, you see, everybody see this right here? Zoom in on it, take the center line, it'll turn red. Once you've got that, drag the line up here, zoom in, and put it on the very outer line, like that. Everybody got that? This is one of those, you have to zoom way in so you don't select the wrong point. Okay, now take a circle. Put it in the middle of that line. Watch my screen for a sec. You see how this goes directly on the middle of the line? That's how I can automatically resize the various diameters, and this hole will always stay dead center. And then the dimension on this one is 3.6. Oh. Divided by 25.4. I should work for NASA. I really should.
How do you constrain the construction line?
Midpoints. Okay. And now we exit the sketch. Let me know once everybody has this.
Does it matter where the center line is in relation to the sides?
It does. It needs to be smack dead in the center. So that's why. Here, let me show you.
I might have not put this on.
So if you, no, you're correct. See that little symbol says mid, and I just know through that line, you're mid on that line, so you're good. Yeah. But we can confirm that later. Okay, is everybody good? Everybody where I am on the screen? To the website? Yeah, they're linked to YouTube. I got those lectures and this to add. Okay. 3.6 millimeters. Okay. Now exit the sketch through the little purple pencil. And now I want this hole to go all the way through the entire gear. So the way we're going to do that is we're going to go mid-plane and do 2 inches. See how it goes all the way through both sides? Everybody there? So that's mid-plane 2 inches. And now hit OK. And now go back into shaded view. just so you know, we're doing real good. Okay. Oh, hey, we're even further along than I thought. Now, does everyone have this on their screen? Okay. We need to add some planes. Sometimes you can't make cuts based on existing surfaces and the existing, front, top, and right planes. So everybody select right plane, and then go up here to the SolidWorks, insert, reference geometry, plane, and select 1 inch. And you'll see a plane pop up below the gear. See? Has everybody got that? And now hit OK. And now we're going to do it. Yeah? Here, watch me do the second one. Right plane, insert, reference geometry, plane, 1. Now it's on the wrong side. When it's on the wrong side, you press the flip button. See? Flip button toggles it back and forth. And hit OK. Yeah, just flip.
Is there a difference between studying like flip versus negative dimensions?
SolidWorks never allows negative dimensions. It always relies on positive and flip, which is annoying. It should be negative, I think. But okay, has everybody got 2 planes? Okay, now if we were to put this in assembly, it would be super annoying because we would see not only a gear, but 2 planes. And we don't want to see planes. So, select the plane, right click, see the little eyeglasses? Hide, goes away. It's still there, it still exists. You can still manipulate it and use it. Now do that to both planes, hide. And go ahead and save. We are about 2/3 done with this part. And as I said, this part is by far the hardest. Actually, more like 3/4. Okay, everybody good? Now, see how when I go over the plane I can see it? That's how you make sure you're selecting the right plane. I want you to select the plane up here above. Do you see this one? Highlight that and do Extrude Cut. And then change to the normal view. And take a circle and put it in the middle of the other circle. Now do you see how when I get near here it auto centers? Like this. Make the circle a little bit bigger. And then smart dimension it to be 6.5 millimeters. 6.5 divided by 25.4. Everybody with me? Okay, now exit the sketch to the purple pencil. And we're going to do an offset from surface. No, just one. Offset from this surface here by 4 millimeters. 4 divided by 25.4. Okay, so it should look like this. Anybody know what this hole is? It's for the head of a screw.
What's you said 4?
4 millimeters. Josh, you doing okay?
No.
6.5 is the diameter of the hole. 4 millimeters is the offset from surface.
One thinking small, one big.
That doesn't matter the size.
How much is the offset?
4. Okay, now you put that in. Okay, does everybody have have an extruded circle? 6.5 millimeters is the diameter.
Why not too big with 6.5.
Divided by 25.4.
Yeah, what was the amount that we cut off when we did the cut extrude to make the whole part stubbier?
We made it so that the width was 8 millimeters.
Okay.
If you want for now, just make the diameter a little smaller so it fits, and then you can go back fix it later.
Yeah, it was 8 millimeters from like.
From the inside surface, not the outside.
Yeah.
That's the difference for you. Hey, can everyone who is on my screen raise their hand?
So you select that and tells you what the last view was. Yeah. It should go from my. No.
Okay, everybody got what I got on my screen? A little slice of awesome sauce. We good? It's funny, you're all like me when you're doing things you can't hear or speak. This is why my wife tells me plenty of things that I end up never hearing. Okay, we good? Okay, hit the little check mark. Okay, this next one is fun. I think you actually really will like this. Select the other plane beneath the other hole. See this one? It's far away from the hole we just made. Select that one and do extruded cut. Now do the normal view. Okay. Now take a circle and center it here on that hole and make it about that size. And don't click. Do for construction. This is reference only. Okay. Now hit escape. Now I'm going to wait and make sure everyone has this before I go ahead, because the next part is critical.
Wait, is it for construction?
And then I clicked yes and I hit escape.
How big is the diameter?
We're going to set that later. Okay, I'm going to do it again. Circle in the center. By the way, if it doesn't appear in the center, right here. See, it's not the center. Right here.
What plane are you sketching on the first plane?
The one furthest away from the last cut we made.
Okay.
Basically, we're making a similar cut in the opposite side. Okay? Put the circle in the center, and now watch my screen for construction. Now we're good. Everybody good?
How big should
Doesn't matter. We're going to size it in a fancy way in just a sec. Okay, now take a solid line. We're going to make a hexagonal hole. So click here and let it auto horizontal and then click on the circle. Then, watch this. I come down here until I smack on that point. Then I go down anywhere, that's fine. Auto align horizontal. Go up to this point that it constrains there. Then go up here. This is not a clean hexagon, I understand that. Just go ahead and do that.
So the first point was arbitrary?
The first point's arbitrary. The only points that do matter are this point here and this point here, that they align on the left and right vertices of a circle if we were to quadrant it. Okay, now once you all are there, let me know. Hexagonal holes blow up quite frequently if you're not careful, so we're going to do it together. The next constraint is quite fun. It's also frustrating. By the way, I have no means of refrigerating that pizza, so anyone who is a starving student, please feel free to take the remainder. Just don't come to fisticuffs over it. Okay, does everybody's thing look sort of like mine? Would anyone like to see this again? Okay. So I take a circle like this, and I hit for construction. OK, escape. Take a line, put it up here at about a 45-degree angle, and do horizontal. Now go down to this point here. It'll auto, see how it highlights it? Now go down somewhere else, horizontal, up here to that point that auto corrects, and then here. It's ugly, but if we, can you see that if we made all of those lines exactly equal, it'd be a hex? Okay, now, everybody with me? Click every single line in the hex while holding the control key. 1 line, 2, 3, 4, 5, 8. You're all still alive. It's a good sign. They're all highlighted. Go down here. See this equal button? Booyah! Hit the check mark. Now it's still blue. Now, I happen to know the size of my hex. No one defines hex in terms of circle diameters. This is why we didn't give a diameter to the circle. And unless you want to be doing cosines and sines, you want to actually do smart dimension and pick one of the lines and go straight across to another line. And select that to 5.5 millimeters.
Where was the equal button?
I'll show you again. Okay, so I select 1, 2, 3, 4, 5, 6, right here. If you don't see the equal button, it might be hidden under add relations, and you press this little thing, see? Okay, check mark, yes, and then dimension it across any of the flats is fine. 5.5 millimeters, so divide by 25.4. Hit this, okay, and now we do offset from surface and select the nearest surface here and do 4 millimeters. So tell me when everybody's looks like this. Is anybody lost and need help?
The hexagon says it's unsolvable.
So this is why hexes explode a lot, because if you click the wrong thing and then hit equal, it gets very upset. Say, for instance, if you were to click a point instead of a line, it would get very upset. Okay, when this happens, now just mark it. If anyone's turns all bright yellow in the sketch and says it's over constrained, it means you added some point that you shouldn't have. Try clicking one of the little point things and hitting delete, and as just happened, it'll go away. Is everybody where I am?
Which surface do we do the cut from?
See this one here, the pink one?
Yeah.
It's basically the next surface that you would intersect.
Can you just quickly repeat what you did after setting them all equal?
Yeah, so then take smart dimension here, and then click between two opposite sides.
Two opposite sides?
Yeah, so flat. Imagine you took it and pinched it between two fingers, and set that to 5.5 millimeters. Like 10.
And that's it?
Almost done. That's it. Everybody good? Offset from surface 4 millimeters. We're just about done. The next couple steps are pretty easy, I seem to recall. They're also fun.
Is it the
This one.
closest?
The one closest. Kirk, you doing okay?
Last time was it also the one closest
Yeah.
to it?
Yeah, but in both cases, it's the one closest.
Okay.
The reason being, we're going to put little hex nuts in there, and we need enough material to make sure it doesn't just rip through the plastic.
Okay.
So you're going to be defining it from the nearest surface so the hex nut doesn't rip through.
Great.
We're almost done, guys.
How much
This-
Always measuring the wrong dimension.
Huh?
How much offset?
4 millimeters. This is like round 7. And the other dude's sweaty and bloody and screaming, Adrian! Only, I don't know where I was going with that. We're almost done. Okay, is everybody where I am? Okay, so you should have a hex hole. I'm going to go ahead and finish up because we're all falling asleep. Hit the check mark. Booyah, we have a hex hole. Let's see what the next step is in my file. Okay, that's good. Okay, the next thing is really cool. You haven't seen this before. It's called a fillet. Everybody go insert. Oh, go ahead and save. We don't want to lose that. The files you generate here, I am perfectly happy for you to just hand them in to me as homework. Okay, insert, features, fillet/round. Okay? And now I want you to set that to 0.5 millimeters. And now we're going to start clicking stuff wildly. Okay, watch this. Watch my screen. I click the edge. This time we're not clicking surfaces, we're clicking edges. If it doesn't show you, hit full preview and it will turn yellow. See that? No preview doesn't show anything. Full preview shows what it will look like. So it's just going to take that corner off by rounding it. We're going to click this edge and this edge, and see in here this edge, and then we're going to click a bunch of other stuff. Okay, once everyone has these four edges, let me know. See this one in here? Here, let me unclick this one. See that one? See, it's the edge right between the flat and the start of the gear teeth. So for fillets, you can either select faces or edges. Edges is safer because you're only selecting one edge. Faces, they're quicker, but they often grab lots of stuff that you don't want to do. In this case, select this face. Oh god, that doesn't work. Select this face. It doesn't work. God damn it. You know what? I'll be happy if you just get these edges and those two faces. Does anyone have fillets at this point? Would anyone like me to show you again how to do fillets?
Yes.
Okay. Insert, feature, fillet. Everybody there? If you have an external monitor at home that's bigger, you might want to use it because otherwise it's going to be painful. I've got this nice shiny Apple Tosh. Okay, we're good? Now set the fillet radius to 0.5 divided by 25.4. And everybody look at my screen. Select this edge here. If that doesn't turn yellow, press full preview. Okay, does everyone have that fillet? Alright, rotate your part and get this edge right here. This one's important. Rotate your part and get this one. Now, let me remind you, we're 3D printing these gears. Does anyone know why I'm taking this edge right here? Yes. Edges, sharp edges, are called stress concentrations. Especially in plastic, it will snap in half if you look at it odd boy ice. If we put this, it's 10 times stronger. Without it, it's going to break. With it, it won't break. Click that edge. Okay? Now click this edge. Does everyone have these 4 edges? Okay? Now I'm going to show you how to do a face. Just so you know, doing fillets on faces, very tricky business. Be careful. Select this face right here. See how it did multiple edges? Now select this face here, right here. Yeah, if all of the lines turn blue and the yellow goes away, it means you can't do that face. And that's okay, that happens a lot. So if that happens, just don't do that face.
You only clicked one face right now, right?
Yeah, this one right here. Now click this face, right here where my mouse is. And that's the only fillets that we're doing. I may have lied.
Where aren't you doing it?
Huh?
Where aren't you doing something? This one?
We'll do some more.
Okay.
That one, this inside edge here. Basically, I'll give you guys a picture of it, and you can add fillets at your leisure. Basically, anywhere where you think it might break, add a fillet. Now that you know how to do fillets, I'm not too worried. Hit OK. Now you see how it's rounded?
So why are we doing it to the faces?
Just because it's easier in clicking all four edges. Okay, we're second to last feature. Actually, what is this? Okay, cool. Guys, we only have one last feature. Everybody with me? Rotate your part. Select this face. Extruded cut. Turn to the normal. Now here's the thing. I want everyone to be proud of the parts they make, and also I want to be able to disambiguate them off of a giant sheet of different parts. So if I ever have you 3D print a part, I need you to put your initials in it. Insert. Actually, just skip that. Everybody see the giant A here? Click the giant A. Now click, type in your initials. See how they've appeared? Now, wherever I click, the bottom left of the text starts. But it's too big. Unclick Use Document Font. Go to Font. Just make it smaller. I don't care how big it is, just don't make it big. See how it's smaller? Now put it around here horizontal. It should be about that size. It doesn't need to be precise. It's just your signature. 1,000 years from now, archaeologists will know that you were here and making gears. Because that's how long it'll take for this plastic to go away. Okay? And now hit the check mark. We're done. Exit the sketch and make it, let's do 0.5 millimeters deep. So just a blind cut. And now see how it turns yellow? Press the green check mark. You're done. Now the last step is I'm just going to explain to you what the hell we just did and why we did it.
Quick question. So we did fillet, and like in class you mentioned that you chamfer it.
Yes.
So what's the difference?
When you 3D print things, sometimes it can get grumpy with sharp edges.
Okay.
If you have the option to chamfer or fillet, I usually fillet just for 3D printed parts. The reason why you don't do that for machined parts is machinists, it's very annoying to have to round things, but they have special tools for chamfering, so it's trivial. They can put a chamfer in the time it takes to...
What's the difference in the two? They both round the edges, right?
No, a chamfer is a sharp angle.
Okay, right.
How many millimeter is the cut for your name?
0.5. So basically, the reason it's 0.5 is because if it's less than that, I won't be able to see it. And if it's bigger than that, it will hurt the structural integrity of your plastic. So, does everyone have your initials printed into your gear? Okay, now I'm going to explain why. So go ahead and look at my screen. Imagine we put a, actually I'll show you this real quick. Take the right plane and the top plane, insert, reference geometry, axis, green check mark. We have an axis. And I'm going to leave this visible. So go ahead and do that. That's the last step. Right plane, top plane with control. Insert, reference geometry, axis. And you'll see the axis pop up. Hit the green check mark. So this axis is where we're going to put a shaft. We want this gear to not move along the shaft. So if we put a screw right through that, to that hole, and we put a nut on the other side, then when we tighten that screw, it will clamp onto the shaft, and it will be rigidly attached to the shaft. The reason we're doing that, does anyone know what a set screw is? A set screw is where you have a screw that drills into the side of the gear through the middle. So here, I'll just show you real quick. Don't do this. set screw would be like a screw through that hole that screws directly into the shaft. They're annoying as hell. Try to use them as little as possible. Whenever you can use, if you use a set screw, you have to put a flat on the shaft so that you don't hurt the outside of the shaft, and then that's just more machining. Clamps don't hurt shafts, and you can tighten them with an Allen key super easy. They never vibrate loose, so that's why we're doing it. So is everyone clear on what we just did? Can someone remind me why we're using fillets? There are two reasons. Strength, and I may not have been loud because it was just the front row. When we 3D print them, sometimes it gets a little grumpy when we have sharp edges. They'll have little burrs on them. When we round the edges, it gets rid of those so we don't have to do much post-processing. Okay, so here's the deal. You just learned tonight all of the basics of making sketches and parts in Solidworks. There are much more advanced things. You won't be doing them for a while. Don't worry about them. At this point, you've done planar and you've done non-planar. You've done all types of cool stuff. You're good to go on parts, except for one thing. So that was kind of nasty. Okay, so I'm gonna ratchet back the difficulty of the starter parts. Don't do too much with the starter cat I posted to the website because it's unnecessarily hard based on how we did tonight. You did great, but I'm gonna ratchet back a little bit. Now the last thing we have to do is assemblies, and you have to do a lot of them. So here's the deal. We can either have another training session on assemblies, or I can record myself doing it and we can post it to the website. I'm happy to do either way. If I do it to the website, you can watch it from home at your leisure. You'll probably have a lot harder time than if you come into class and do it. Again, I'm here most of the time either way. It's mainly your guys' convenience. So show of hands, this is Easter weekend, so we won't be doing it until after, on or after Monday. Who would rather watch this on YouTube for doing assemblies? And who would rather have a second one of these? Now keep them. Those are the two options.
One of those two options.
Awesome. We have a yes, no, maybe man. So let's do a show of hands for YouTube. Let's have a show. That's 4. Let's have a show of hands for in class. Okay, so we'll have another in class session or in room session. Unfortunately, not trying to be mean, we can't do it in class because it's if we do nothing but SolidWorks, then we'll do no mechanical design. We have to do them both. Now, here's my promise. As I said, this class, in terms of workload versus time, so this is now, and this is June, and this is effort, and it's going to do this. So right now we're really high, and then we're going to get better and better, and this is going to be all mechanical design in here, all mechanical design. This is safety training, and buying mice, and doing SolidWorks, and this is robot arms. And this is learning. Well, this is learning too, but anyway. So my wife was reminding me last night that half of you are going to drop if I do stuff like scheduling things on Easter Sunday. So don't drop. Don't be terrified. I know this is really difficult and frustrating, and I've been doing this for years. We're getting here, and at the end we'll have a robot arm. For the next week, it's going to be tough. We've got Clark safety training, PRL safety training. I got to train you on tools in the shop. You got to come back for a second SolidWorks training. It's okay. I promise you, it will only last through the next Friday. And I'm going to push back Lab 1 so that you're not all crazy. If we need to do one less lab this quarter so that you don't do Harry Carry, that's fine. I'm okay with that. But, so I'll schedule another one on or after Monday for just SolidWorks assemblies. I will post this online probably tomorrow. It's up to you. You should probably do this gear again if you can. If you don't want to, that's fine. You can turn it in as is. But you should probably do it again. And in terms of the other parts, this is the only non-planar part. No, there's one other non-planar part in the homework, but it's pretty simple. And then the rest is all planar. Okay? So it's just sketches and extrude and you're done. And then other than that, it's just assemblies. Assemblies are super easy. It's monkey clicking for 2 hours. You have to start early. As soon as I assign it, start it. This is not because I think I'm important. This is because it takes monkey clicking for hours. And because you guys are just starting, it will take longer than it takes me. And it took me 2 hours. So click, click, click until you're done. If you have any questions whatsoever, email me. And you can bring your laptop to my office hours and we'll go over it. Any other questions? Awesome. Just so you know, you did really well. I'm very pleased.